Continuing with worksheet 2 of differential equations. Number 6, for what value of k, if any, is this y equation, the solution to the differential equation 4y minus y double prime is equal to 10e to the 3x, 10e to the negative 3x. So let's go ahead and work our way down to y double prime so that we can make our decision better as to how things fit. So I'm going to work my way to y double prime. The rule for e to the u is e to the u times u prime. So e to the 2x becomes e to the 2x times 2. Again, k is just a number, so treat k like a coefficient. So really just have to find the derivative for e to the negative 3x. The rule for e to the negative 3x is e to the negative 3x times negative 3. Clean this up, we get 2e to the 2x minus 3k e to the negative 3x. So now we're going to repeat the process, find the derivative again, so we can work our way down to the second derivative. E to the 2x becomes e to the 2x times 2. E to the negative 3x becomes e to the negative 3x times negative 3. Multiply the respective coefficients together. 2 times 2 is 4. Negative 3 times negative 3 is a positive 9. So now we have our second derivative in front of us. Let's make our substitutions back into this differential equation and see if we're able to solve for k. So replace the y with the original equation. Okay. Replace the y double prime with what we found down here, 4e to the 2x plus 9ke to the negative 3x. Let's careful. Separate these out using parentheses so that this negative will end up being distributed through both terms. And then 10e to the 3x, we can just leave it in that form. Okay, distribute the 4 through, distribute the negative 1 through, and now once I do that, I see I have like terms here. Goes to 0. Here, the k's combines to be 4k minus 9k is negative 5k, e to the negative 3x. And now I can solve for k, divide both sides by negative 5 e to the negative 3x. The e's cancel out. 10 divided by negative 5 is negative 2. So answer choice A. Same idea. Number 7, we're going to work our way down to y double prime, make our substitutions, and see if we can solve for k. So here's our y equation. The derivative for e to the u is e to the u times u prime. Cosine of u becomes negative sine of u times u prime. Clean that up. We have our y prime equation. Repeat the process to work our way down to y double prime. E to the u becomes e to the u times u prime. And then sine of u becomes negative cosine of u times u prime. Multiply the coefficients together. We get negative 2 times negative 2 is positive 4. Multiply the 3 and negative 12, we get negative 36. So now let's make our substitutions. Replace y double prime with what we found here. Replace y with our original equation. And the right side will stay as 26e to the negative 2x. Let's distribute the 9 through. And let's see what like terms we have. The cosines conveniently cancels out. Combine these like terms. 4k plus 9k is 13k e to the negative 2x. Divide both sides by e to the negative 2x. Sorry, 13 e to the negative 2x. The e's cancel out. 26 divided by 13 is 2, so k is equal to 2. Answer choice A. All right, number 8, similar to ones that we've seen before in the past, where which of the following are solutions to the differential equation? We're going to find y prime and y double prime for each of these equations, and then once we find those respective ones, we'll plug them in separately and see which of those will allow for the differential equation to still stand true. So let's look at the first option first. Sine of u becomes, let's work our way down to the second derivative. Sine of u becomes cosine of u times u prime. Okay, times 4. So I already moved the 8 here. So sine of cosine of u times u prime, cosine of 4x times 4. 4 times 2 is 8. And then the derivative for cosine of u is negative sine of u times u prime. So that 4 times 8, that negative 4 times 8 will become negative 32. So let's replace y double prime and y prime and the y. So y double prime gets replaced with negative 32 sine of 4x. Y prime gets replaced with 8 cosine 4x. And y gets replaced with 2 sine 4x. We get negative 32 minus 48 plus 16. And if we add those together, we're not going to be able to get everything to cancel out to be 0. So this is option 1 is not a solution. Let's look at numeral 2, Roman number 2. E to the 2x becomes e to 2x times 2. Second derivative, 6e to 2x becomes 6e to 2x times 2, which is 12e to the 2x. Make our substitutions here. 12e to 2x gets replacing y double prime. Y prime gets replaced with 6e to the 2x. Y gets replaced with e to the 2x. Combine this, we get 12 minus 36 plus 24, and these do combine to be 0. Right, third option, c e to the 4x. The derivative is e to the 4x times 4 with the c in front. The derivative for e to the 4x again is e to the 4x times 4 with the 4 in front, so this becomes 16. Make our substitutions. Y double prime gets replaced with 16 ce to the 4x. Y prime gets replaced with 4 ce to the 4x. Y becomes ce to the 4x. 16 minus 24 plus 8 does go to 0, so options 2 and 3 fit, but not 1, so answer choice D. Number 9 feels the same way. We're going to work our way down to y double prime so that we can decide which of these will allow us to solve, or so we can work our way down to solve for k. So we're going to work our way to y double prime. So the rule for e to the u is e to the u times u prime. E to the 4x becomes e to the 4x times 4. We clean this up. We get negative 2e to the 2x plus 4k e to the 4x. Again, treat k like you would a constant, a number. Moving our way to our second derivative, e to the negative 2x becomes e to the negative 2x times negative 2. E to the 4x becomes e to the 4x times 4. Clean this up. We get 4e to the negative 2x plus 16k e to the 4x. All right, let's make our substitutions here. So we'll replace y with our original equation, e to the negative 2x plus k e to the 4x. That's here. Y double prime over 4, I'm going to rewrite it as 1/4 y double prime so that I don't have to stare at a fraction below my y double prime. Y double prime gets replaced, 4e to the negative 2x plus 16k e to the 4x. The right side stays the same. Now I'm going to try to clean this up here. I'm going to distribute the negative 1/4 through. So 4 divided by 4 is just 1 with negative in front. 16 divided by negative 4 is just negative 4. Combine some like terms here. E to the negative 2x and this negative e to the negative 2x cancels out. Combine like terms. 1k minus 4k is negative 3k. The right side is just 5e to the 4x. Okay, so now we can try to solve for k, right? Divide both sides by negative 3. E to the 4x, the e's cancel out. 5 over negative 3 is equal to k, so answer choice A, negative 5 over 3.